Right, let's start. So, hopefully there won't be that many more students attending this lecture physically. If so, we will be in some kind of deep trouble. Today's topic and the forthcoming 2 or 3 of them will be about database design, which is a topic that sometimes it's quite easy to explain what it is, but it's really hard to perform. And there's an example that I will walk you through, and if there is time, I'll have another one for you that has to do with something that is quite common in Sweden, at least, and that is the vehicle inspection process, also known as bilprovningen. And for all of you who has failed that inspection knows exactly what I am talking about. So this is a life cycle of a database, and you might know the notation because it's from the UML, Unified Modeling Language, and where we are standing right now is on the top of it, which says information requirements. And that is something that is sometimes quite neglected, but it sort of pays off in a very bad taste later on. It's a hard process, and the way it's done here, it looks like more like the waterfall method of developing systems. And when you're done with that requirement phase, you sort of kick over to your logical design of your database. And that's where you go from your models into SQL tables sometimes, and then you start to iterate over those 2 phases, and hopefully at the end you come out with something that is a normalized database model. And normalizing is partly a way of getting rid of redundancies and some other problems, and we will have a look at that as well. For those of you who has been creating databases before without having much of an afterthought, certainly ends up with a real mess of columns in a few tables. So that is one of the things we will talk about when we're having a look at that normalization process. So we're mostly in the logical design square, having a look. And I don't know how many of you who has been studying software engineering. A few of you, yeah. Then you also know that there are a few phases there and a few methods for doing that. And one of them is for creating the requirement specification. And some people really don't like requirement specifications and moves over to some agile process. But there are requirements in those agile processes as well. They are called usually user stories, and Scrum is one specific agile process that uses user stories, and they are a kind of a requirement. So when you are trying to find your requirements, you need to find the right people, and you have to ask them the right questions, and that is something that is quite hard, and that is due to that your customer sometimes don't know what they want. They give you the impression that they know exactly what they want, but actually they don't. And sometimes that it takes a while for you to figure out that they don't know what they want, they are just talking. So getting the right people is really important. But a simple way if you want to impose this on your customer is to use something that is called a domain model, and that's part of the UML and the OMT. And that is quite handy, and that's something that me myself is using quite frequently when talking to the customer at the beginning. And that's a domain model is a sort of a glossary on a model form instead. So, a simple way to start to figure out the requirements is to find the nouns and the verbs and the adjectives. And I'm usually starting with the nouns because that's the simplest version of it. And I try to find and create a list of them. I get a piece of paper and I'm starting to write down my nouns that I find. And you might get, if you're lucky, you get some kind of story from your customer. And from that story or that piece of paper, you write down those nouns or verbs or adjectives. And from that on, you at least have a starting point for creating your first model of your database. And I'll show you a fairly simple modeling technique for that using the entity relationship model. And you can use it if you teach your customer how to use it. And that is sometimes a good way forward in your designing process. So sometimes you can use that entity relationship modeling technique directly on your customer. A bit of teaching might be required. Right. And a few steps. You try to start the whole thing by creating your conceptual model, and we are talking about concepts, and they are sometimes not the real tables. They will be in the end with a few modifications, but they are just concepts. And then you try to create your relational model, and that is more of a process of getting into near like table state, and then you also try to normalize your model. And that normalizing part is sometimes a bit more difficult because you have to check your tables so they don't contain certain conditions, and there are a lot of checking here, but some of these are fairly easy, some of them are not. And hopefully I can give you a few examples what happens when you don't normalize your tables. Because it ends up with a real mess. And that might not be a problem at the beginning of your system, but if it runs for several years and you are adding, let's say, 100 rows a day, it will end up with a complexity that it's really hard to get out of and make it sort of a simpler system again. It's almost that you have to redesign everything from the very beginning. And if you are redesigning your database or your tables, then you are affecting your software. And I think I mentioned that in the previous lecture, that if you are changing your tables that much conceptually or your layout so much that the software has to be changed, then you might not be so popular in your organization. Or at least you will have you need to have a strategy for moving from the older version over to the newer one. And in the end, it's the users who are being affected. So those three steps are the main ones. And that is the entity relationship model, known as the ER model. It's an abstract thing. You are going to use boxes, rectangles, and diamonds, and drawing lines between those rectangles. And each component here means something. And it says here that it's mainly used for modeling databases. And I should point out that there are other notations here. For instance, UML is one of them. And they have also a few other notations in their bag. But if you would move between those different kind of modeling techniques, they are not really exactly the same thing, but they have a few common grounds at least. And it also says here that it's a simple and a fast modeling technique. Yeah, it is very simple for me to tell you what it is and how it works, But you have to remember, when you start working on a problem, the ER modeling technique is just a technique. It doesn't think for you. You are the one who are thinking. You are the one who are modeling. So don't rely on the ER model for in terms of thinking. It's not used for that. If there are a few minutes over in either this lecture or some other, I can show you a few different techniques for that as well. And these are the elements. You have at least two of them here, and an entity, it says, is an abstract thing. So that could be one of your nouns, for instance, and it can be essentially anything. It could be, let's say, a person, or a room, or a table, or a chair. And let's say that we have an entity that is a room. Then we also have something that is called an attribute, and the attribute might be the number of persons inside it when we're having a lecture, or it might be how many tables there are in here. So it might be anything that you feel like, okay, I am contributing to my own database model here. What you do sometimes is that you sort of mix attributes with entities. So something that should be an entity is an attribute, and the other way around. But that is something that you usually find out along the process of your modeling. So don't be afraid to start in the wrong end here. It will fix itself as long as you are paying attention to the details or the context itself. So it's a good modeling technique for changing things. And if you don't know exactly how to do it, just start somewhere. So if you are modeling this building, well, start with the entity called building, and it has rooms, and it has chairs and students. And when you have found those entities and those attributes, you have drawn your boxes, then you try to find the relationship between those entities. And for those of you who are programmers in here, an entity is a class, and the relationship here is an association, if you are an UML guy. But anyway, so you found your entities, you feel quite happy, and then you try to figure out how do these entities relate to each other. And as soon as you find a relationship between two entities, you just draw a line between those two. And suddenly you can sort of read the diagram and almost make a sort of a novel of it if you want to. However, when you have those relationships or your associations, you usually put a name there. That's the name of the relationship, and that's what you put inside that diamond. So if you're reading this, then you're saying that a star stars in a movie. And a movie contains of stars. So it might be read both ways if you want to. And also there's a cardinality going on here as well. And then you have to look at where the line meets the box. That's the sort of junction here. And it says nothing. So that means it can contain of 0 or more. So a movie might contain of more 0 or more stars, and the other way around. So, and And this is what I meant by when I told you that this can be taught to a customer fairly easy. So what you are doing is that you are doing the modeling for them, and they sort of verify it for you. Okay? And that cardinality is also called multiplicity, and you have at least three. Well, there are a few other ones. One to many, many to one, and many to many. So if you put an arrow at the end, it means a 0 or 1. So this means that a president runs one studio, and a studio can be run by a president. So this means that a studio may not be run by more than one, because if that would be the case, I would have to remove that arrow. Then it means many. That means a studio can be run by many presidents. Here we just say it can be run by a president, but it can also be 0 presidents. So that means 0 or 1. And there are a few other versions on this. Let's see if I can move over here. So I can actually put a condition there, which means that a studio can be run by 3 or less presidents at the same time. And if you are using the UML notation, I can actually do this, which means that 3 or less, or exactly 7 presidents. So that one, which meant 0 or 1, could easily be written that way. So if you want to, you can be a bit more explicit. Choose whatever you feel like. It should make you perhaps a bit more comfortable if you are using those more exact conditions, but it's up to you. And for those of you who knows how to model things in UML, knows that you can use that thing in a class diagram as well. Okay, so 1 to many, many to one, or 1 to one. Those are the things. And there are also something called multi-way relationships, or ternary, because sometimes you need a relationship, and that relationship is connected to some other entity. If you have the relationship of a contract, then you have a star entity, a movie entity, and a studio entity. So that contract somehow has these 3 parts in common. It might sound a bit strange, but it's not. You will eventually run into this problem in the future, but you just have to remember that you are actually allowed to add more entities to a relationship. It doesn't have to be binary using 2, it can be more. And the same goes, and we'll have a look at that in a moment. A relationship might also have a property or an attribute. So, an example here, and it comes from Diva, which is something that this university is a part of, and it's an academic archive going online where you can upload your thesis, or a researcher can upload a paper, or you as a student can probably upload a paper as well if you want to, if you have it granted. And then you can also search in it. So if you are interested in something and you know what search word you were looking for, well, go to DIVA and search. And perhaps if you're lucky, you find your paper so that some other researcher or student has written earlier. The link is down there if you wanted to have a look at it right away. So I thought that we should have a look at this site and see if we could create a model from it. So this is a bit backward. I'm doing it backward. The site is there, but let's see if we can make a model of it anyway. Okay? And if you do a search, you will end up with a list, and that's the list of hits, search hits. And we had a look at this before, and I thought I said that, okay, this looks really like a comma-separated file from Excel, and it probably is. And this is also what you get out of it, and there are a few writers here, and there is also an identity. So somehow, whatever a writer has created, a paper or something else, it has an identity, and that seems to be important here. That sort of points out that paper. So I cannot interchange that paper with some other paper because it's unique. And there is also a year and a type of what that person did upload. And there is also something there that's a level indicator at the end, which has to do with the quality. Sorry, that's not the quality, that's on what level that paper is on. Is it a research paper, or is it a master thesis, or something else? But if you would take that, comma-separated file and have a look at the row header, the first line, and then you try to create a model from that, then you might end up here. You might end up here. If you would do this, you might use different entities, different attributes here. That's fine. So this is what we came up with, and we came up with the idea that, okay, this is a classification system, because it sort of is, because you can also rate your paper here for quality, for instance. So the classification is something that is put into the center of everything, and the question, is that right or wrong? Well, let's find out. But first of all, we have a few attributes: the author, the type, the year, the level, and that ID that DIVA is using. So don't be afraid to start somewhere. It's better that you start modeling than being afraid and not starting. So this is where we started. So that first question here, is that ID used in DIVA a good attribute? Which is a question. I don't think it is, but this is a part of your modeling. You have you sit down and talk to your friends about this and come to the conclusion, all right, okay, it might not be that good that that's an attribute. It probably is an entity somewhere. So you remove that DIVA attribute, you create an entity from it instead, and then you have to put a relationship between those two. Because if you start to have entities not connected somehow, then you might having a problem. The cause for that, well, I don't know. Perhaps you are you're not finished with your thinking, or you have been given the wrong information from the customer. So there are many reasons. So when you start ending up with those tables or entities just lying around, not connecting to anything, just think again. Sometimes you need those extra tables. Well, that's another matter, not from this course. So, okay, we have our classification entity and we have our diva entity, and we somehow feel that, okay, this is a relationship. They are associated with each other somehow. So you draw that line and put that diamond there and start to think about, okay, what is that diamond? What is the purpose of the relationship? And then you start to think more about this. Okay, is that author and year, is that actually a classification? That sounds really off here. Sounds like something entirely different. So why should a classification have an author? Okay, let's see if we can do something about that. So we're stepping back. And this is a normal process. This is a normal process when you create things in the software world. So let's go back and think about this. And let's step out here and get a greater context of it and see that, okay, what we're trying to figure out here is how to measure volume and quality here somehow for our papers. That seems to be really important. So if we have that context, perhaps we can start to remove things or add some things here. But it seems really strange that the classification has an author and a year, because we want to know whether that published paper, is it any good? And also, if you are publishing something, how does your paper get graded in terms of quality? That might be a difficult task. So if you go with that your papers or whatever you upload is going by volume and quality, then it means that the more you are publishing, the better it is. So, okay, so we are talking really about performance here. So if we are talking about performance here instead, then you have a researcher that is to be graded somehow, and it also has probably a paper. So that might be the identity of that published paper. Can you see that that's the sort of a connection here? We are somehow trying to relate the researcher and their papers and somehow store its performance. If you would do an Excel sheet of this, then you would have 2 columns, or at least 3 columns. The researcher, the identity of that paper, and the performance. But don't think in those terms yet. We are on a conceptual level here. If you want to, you can think in terms of classes, because then you have a class named performance, and you have a few attributes here, or properties, such as the researchers and the published ID, and probably a bit more. So let's go back to that quality thing. So let's assume that we have that quality score, that grade, so that goes from 0 to 2, where 0 is not very good and 2 is very good, it's excellent. So that's our grading mechanism, from 0 to 2. So we are adding another attribute here. Now we are getting somewhere here. We have the researcher, which might be one or more of them. Let's just think in terms of a researcher. That researcher's published paper and its quality, and that's our performance. All right? So, if we would draw this, take a piece of paper and make up a fake table just to have a look at it, that's fine. Or if you want to fire up Excel or any of the other Excel clones out there, then you would probably create these 3 columns. The author, the publication, and the quality. And then you would start to add rows. And this much looks like a table. So, Nadim has published a paper with that identity and has been given the quality score of 1. And Victor has been given the score of also 1, and Talib 0. So this is our way, as we are right now, how to somehow remember and store the performance of published papers. Okay? And here we go again. Okay, so let's start thinking about this again, that those domains and those requirements. So how is actually that quality determined? Well, we have just come up with our own sort of measuring here. I don't know whether it is good or bad, but if that's what you have, well, then that's what you're modeling. And actually, what is it that we want to measure? That is also one of those items you might be thinking of. We are just putting a number here. Where do we get it from? What we have here is only individual researchers. If we go back here, what if that publication that Nadim created here ends with 16? What if they were 2 or more? Well, then our model can't handle it. Not the way we are doing it right now. Or, do you see how I'm trying to making some logic of this? Thinking and moving ahead. And this is actually what you are doing when you are creating your programs or making your electrical design diagrams.
So we basically need to add an ID so we can get a unique identity for each author.
Yeah, the question here is if we need to add an extra ID to make the pairs or combinations of authors unique. Yeah, yeah, that is one way of doing it. And that might be something that we actually do in the end. But let's see if we end up there. So, what we have here is a Norwegian site that is very good at exactly what we are looking for, that quality. How should that be determined? And let's have a look at that Norwegian site in terms of modeling. Where does that site fit in? that might be one version of it. Let's see if we can either use this technology where we are connecting our system to a remote one and try to fetch data from it into our system using a web service or something, or a TCP IP protocol. Or do we just copy what they are doing over there, their conceptual model, into ours? Either way, we are having a look at that Norwegian way of measuring quality. So that's just a short thing here. So that Norwegian site is very good at that, and if you would study it, you would find that it has a few attributes here: the title, the international title, and so on, and its level, and the publisher, and the URL, and so on. So what you need to see here is that what we called quality score is called level by that site. And as my previous lecturer has noted, it is tracked from back from 2004. So there are a few more attributes here. So if we sort of sneak at that Norwegian site, NSD, let's copy that way of thinking. Then we suddenly have our performance, and we have a relationship to NSD, and that's not a TCP thing, that's not a web service thing here, it's just a relationship. And that NSD has an attribute that is called level, which was our quality. Okay, so looking at what others do is sometimes really good, and copy their way of doing things. Don't copy the system, the site itself, because you will be in deep trouble, because you are stealing. And that's the next question: what do we actually want to measure in times and time intervals? Are we talking about a few years, few months? Is that a variable that we have to take into account? Is it an attribute, or what is it? Should the collaborators of a paper be taken into account? And if that is so, is it that good, or is it bad? What if a collaborator is a lot better than the others, and then the paper get a bad level, and that person is dragged down? So what we have here is that, okay, let's go with the effort. Our performance is the effort. And those individual researchers, should we have multiple of them? The teams, the groups, and they also actually talks about divisions and departments. Do we need to take titles into account? Should we compare a full-fledged professor with an assistant? I'm just asking questions here. If the question is, no, we don't care about that, well, then get rid of that title thing. So I'm mainly thinking out loud here. And I should also point out that if you would be doing this, then you might say, yes, this is very important to have that title attribute here. Then you add it. Okay? So, performance is determined by volume and the quality level, and we get the quality level per publication from NSD. They have the good system here. We learned it from that system, conceptually at least. Okay, so that's where we are. The performance has two attributes, researcher and publication, and is related somehow to the NSD way of doing things. An NSD entity, and it has a level attribute. So, and if you could read this, then you had a performance could consist of 0 or more NSD levels. So that might not be correct here. Let's see what happens here. Okay, that might be not so good. So that performance thing is probably something that is not so good at this point. We are actually talking about publications instead. If you go back, have a look at that. The publications, the research, and the performance, well, might not actually be what we're looking for here. So the author and the publication is what we're looking at here. And what if we have another look at these things? If we would have to look at the working stations here, the working situations here, then we would probably have a few more attributes. And those attributes is something that you are looking for when you are conducting interviews or reading about this university. And perhaps they are of interest, or they aren't of interest. So there are perhaps a few: the position, the faculty, department, volume. Okay. They might not be there. They don't contribute anything at all to whatever we are trying to modeling here. And this is also one of those design decisions. We are just talking about journals, articles published in journals. So we don't care about conferences, and we don't care about books. And we also need to have a system for that manual inspection. So somehow we need to store things so that the author or the authors might have to verify that, okay, if this is correct or this is not correct. So a publication might consist of that: a title, the journal itself, the number of it, volume, and the year, and the publisher, and so on, and the number of authors. And that's an example of it. So is that something that we need to take into account when we're talking about a researcher? Its title, its division, department. Is it a full-time or a part-time? Its type of employment. And it's not easy for us right now, to determine whether that is okay or not. Sometimes it's better to add too much than too little, because sometimes it's easier to remove than to add in after a while. So that would be an example. And I should point out, sometimes it's really good to create those Excel sheets and start putting in data just to get the feel for it. What is it that I am actually adding here? I don't think that many of you will do. I seldom do it, but I should do it more often, just to get the hang of it. What am I adding here? I mean, it's like if you start adding rows, then after a while you probably end up in a corner. You're totally cornered. You can't add what you want to add. Well, then you have just found a problem with your model. You're lacking an attribute or something. But as I said, I seldom do it, but I should be doing it more often. And sometimes you get a bit cocky and think that this is the system. I've found the model. I'm done. and usually you're not. So this is where you would probably end up after a while. Should we have a look at it after a break? A 15-minute break? Okay.
what is our manufacturing from some China fact.
Yeah.
Okay, let's start again. As I said, this is something that you probably will end up with, or near like it at least. Or you might end up with something entirely different, which might be okay. I mean, sort of we're taking things out of its context. So you might end up with a very different model. But as long as you are solving the problem at the end, then you're fine. And I should also mention that these modelings or diagrams is a good way of getting really angry at each other, because you probably have different views of the topics you are talking about. But that's a good thing, as long as you at the end come to an agreement that, okay, this is what we're supposed to do and this is our way forward. But talking is good. So now you know that a researcher is an entity, as well as the publication box, that's an entity, and then you have a relation or an association between those two. So a researcher has authored a publication, and the researcher has the attributes of a name, title, it's the faculty and the department and so on, and the publication also has a few attributes like title, year, status, and so on. And what you probably end up with is those two tables. If you would do it from this model right now, it would be a researcher table and a few columns, and a publication table and a few columns, and probably also a third column, a third table called authored by or something, which connects these two. So, okay. But what if we want to have that quality level adjusted every year? What if we want that quality level to be adjusted every year? That level. Well, we could put it as an attribute to the publication, but that year that is over here is not the year where we add a new quality to it. That's the year when it was published. So if we put quality here, we are ending up with a new instance of that publication entity, and then we are adding redundancy to our system, because that published whatever it is coming back once more, with the only difference that it has a new quality set to it. So it seems quite like a bad idea to put that quality property or quality attribute to the publication entity. Can you see that you are creating one instance of that publication, and then you add year to it? Okay, the next year should you add another instance of the same publication, because it will get a new quality level. That seems quite strange. Okay, so then we come up with this idea that, okay, let's create a new entity called quality that has the attribute named level that we were talking about earlier today, sorry. And the relationship is, or association is, that the publication has a quality. And if we would read this correctly, we could have a look at that junction there, which means 0 or more. So let's skip that 0 or more part for now. We can model that later on, but because if we add something such as it has to has 1 or more, then you also need to specify that when you're creating a new row of publication, you also need to create that quality row found in the quality. So the first one didn't really solve it, so we are adding the year. So suddenly we can have one publication and we can have the relationship to the quality where we store the level and the year. So each new year we are adding a new entity, sorry, a new instance of that quality entity. And then we're sort of fixed. Or can we put things elsewhere? Can you see that if I want to say I'm creating a new instance of that quality, well, I see it as I am creating a new row in a table. I have a table named quality. And this is not the this is just half of it, because there is more to it than this. So what you see here is not the end product of things, okay? Because this won't work really. The quality table, it has 2 columns, level and year. The level is 1 at year 2017 and it's 2 at 2016. So it went down a bit compared to last year. So, but remember, this is not the end product of this table. There is more to it, but you can think in these terms sometimes when you see that, okay, I can add another row. That means, okay, I can actually remember the year and the level somehow. And I can relate the quality to a publication. I can relate the quality to a publication. So somehow there's a publication table somewhere. So that's the next version of it. Well, let's remove that quality entity, and put it as a property to the relationship. Well, then you don't remember the year anyway. So that might not be any better. Or if you add the year, the quality of the year, somehow to that relationship. So just notice how I'm just thinking here. I'm thinking out loud. Is it better to have it as a property to a relationship, or should it be that we are creating another entity and adding it to that entity? So I have a few options here. And once again, at a certain point, if we were doing this differently, then we could come up with, okay, that's fine. That suits our needs, and we're done. Okay. That's one of the things we actually doing here. We are trying to capture the real world. We're trying to model the real world. And you all know by now that it's really, really hard sometimes. And another thing is that this is something that you should avoid. And we will come back to these things later on. And that is to avoid redundancy. Redundancy is not always bad. Sometimes when you need speed, you use redundancy for that. But generally, try to avoid it. And by redundancy, I mean that I'm storing the same information on several entities. And that also imposes another problem that I talked about last lecture, and that is if I am changing that redundancy in one instance, at one entity set, then I need to change it elsewhere too. Otherwise, I have a reference problem here. I don't know which one of these attributes are actually correct. And that's a massive problem. And you also know, I think that simple is good, but you also know that making things simple is really hard. I think that all of us, me including, can come up with a solution to a problem. But it usually ends up, in at least the first version, as a very complex thing. It solves the problem. But as soon as you start to modify your system, you are sort of running into a corner and you won't get out of it. So creating simple solutions is quite hard. So, so as for now, that is our solution. We put that quality thing as a quality entity, having those two attributes, level and year. So, are we done? No, we're not done. There are a few more levels to this, and if this would be a real situation, I would probably sit down with my customer and have a discussion with them and trying to explain to them that this is the way I see it. And they have to at least say yes or no. And then I would go and move over to normalization or some other steps. And we're also not done, because I am going to give you another example here, which is entirely on the whiteboard. And I hope that you have at least gotten a small grasp of things here. The entity, the relationship, and the attribute. You get quite along with those three things here. So, some of you have heard of Bilprovningen and know that that is a terrible place if you know that your car is not working as it should. I think most of us has been there, at least if you have a non-new car. And it's a place for vehicle inspection. So each year, if you have an older car, I think it's 3 years or older, the authorities says that you have to inspect your car every year. And depending on your registration number you have on your car, your plate, you are designated a specific area, a specific period during the year. So I think I have mine somewhere between March and May, I think. And there's a final date for that. If you pass that final date, then you are not allowed to drive your car. And the way it goes is that you get your invitation. Sometimes they're kind enough, they sort of pre-book you. And then you can pay for that, either online or at the site when you're driving a car to that inspection service. They check it for you. They drive it into a massive hall and they check it for you. They're running around like crazy. checking things like is your steering wheel okay, brakes working, lights working, and all that stuff. And they have grades that goes from 1 to 3. And if it's 1, it's graded as a 1, then you're okay. If it's a 3, then you're stopped. Your car has to be driven directly to a service station where they can fix it. And if it's a 2, then you have, I think, a month to fix that problem again. So we are all looking for 1s. We are sometimes very happy that we ended up with a grade 2 because we thought it would be a grade 3. And sometimes it's the other way around. You end up with a grade 3, your car is stopped, and you thought you would pass it easily. So, if we would start to write down a few words. That's short for Bilprovningen. That's the name of the organization that performs those inspections, Bilprovningen. I have been talking about car, or at least a vehicle, because it's motorcycles and cars and a few other things. I've been talking about an inspection, a station, and I mentioned the word service here, and a person or a customer. Nowadays we are treated as customers. That didn't happen 20 years ago, and we were seen as persons, and that's the kind word for it, can I tell you. So let's see if we can create a conceptual model of this. It seems like that these words I've written down here, they are somehow entities. They are entities. If I'm starting with the word customer, and I will, so if you are using ink when you are drawing this, wait a while, because I will erase a few things here. So I have a customer, and I have a car. I didn't write down a car. So a customer and the customer's car. So there seems to be a relationship between those two. So the question is what the relationship is. How are they associated here? Well, I think that a customer can own a car. And let's just have a short look at this relationship here. A customer owns 0 or more cars. All right, that's fine. That's okay. A car can be owned by 0 or more customers. No. It can only have just one owner. So let's see if we can just add this one here. There's another symbol for it. I didn't show you to it. It will come in a later lecture. And that has to do with referential integrity. So we're sort of, okay, that feels good. A customer can own many cars, and a car can only be owned by one customer. All right, so let's add the organization. That's where the customer is a customer. Do you see where I'm getting? The customer is a customer. So if I would like this, I would like it that way. So somehow that customer thing there is wrong. It's probably a person. And I was writing down car here. Well, you could be having a motorcycle. So that seems to be wrong as well. We are very specific here. We are too specific. So let's add that to a vehicle instead. That organization can have many persons, and a person can be attached to. I wonder if we have to model that, but if we, there is only one bilprovningen. So let's leave it at that, because I think that that entity shouldn't be here, because we are doing our model for bilprovningen. That's why it becomes so strange here. So, okay, the person is a customer. That probably won't end up being an entity, because we're doing it for bilprovningen itself. The person owns many vehicles. A vehicle can only be owned by one person. So that's fine. Then we have a station. And let's leave it for a while like that. Somehow there's a relationship between those two.
When you say has, station.
Has, yeah. I think it would be better if you would end up with something something bit more declarative here. But let's put has here. And when you are being pre-booked, you are assigned a time slot at a service station that is near to your home address. So there are several stations out there. There's one where I am coming from, that's Karlshamn, and there's probably at least one here in Växjö as well. So your car or vehicle has been booked somewhere at some station. So there should be a relationship between those two as well. And I should, don't, you ink guys, don't draw yet. A vehicle is going to service at a specific station. And it's going to 1. Actually, you can book it at a different station if you want to in a different city. But while it is booked, it is. So 1. Or 0 or 1. It is not booked. Yeah? It's not booked. Or it is. Okay. A vehicle is going to service to a station. And the station can be servicing a lot of vehicles. All right. That station probably has an address. Just for adding a few things here, and the vehicle has an ID. Damn it. Sorry, you are not allowed to swear. The service thing here, okay. Where do we store the fact that we did pass or fail? Is it possible to add it to that relationship? Yeah, let's do that. Or should we have it to set it to a grade instead? 1, 2, 3. Yeah.
Why you added to the relationship? Why not an extension?
Because I want to know whether my vehicle has gotten the grade 1, 2, 3. Did it pass or did it fail? So let's see if we can add fake a table and start adding things here. So, but I don't feel that comfortable with the word to service. It feels more like, okay, my vehicle is going for an inspection to a station. And suddenly that grade thing feels a lot better. It has a date. Oh. And it has been paid or not. So, I have a car that needs inspection at a specific station. The result of the inspection is a grade in general. I think it probably should say passed or failed, because there are those individual checklist points that get the grade 1, 2, 3. The inspection was due for a specific date. And probably we had that last date as well. If you pass that last date, then your car is automatically forbidden to be driven. And we also need to know whether we have paid for that inspection or not, because I could prepay it. Or I can do it when I'm entering the station and they have done that inspection, and then you sort of pay your I don't remember, 300, perhaps 400. So you could also add a few more things here, like personnel. And I'm not going to dive into that thing, but just to show you that we're sort of done here. This feels, we're comfortable. We can accomplish our tasks with this very simple model. I have omitted a few things here, a few attributes and a few other entities. But I hope that you can follow my way of thinking here. So at a later stage, we find out that, okay, we need to remember our personnel as well. So you add a personnel entity.
You mean employee?
Yeah. So that is employees. Okay, let's see if we can fit that one in there, which we can't. Employees.
But like, doesn't be proven as well as like employees as well?
Sorry?
Employees?
Yeah. Is that something we should do? Say that the employees are actually employed by Bilprovningen, and that station has staff instead?
But we have a head office also, so it can be both.
Yeah, you see? So if you have a head office, there will be some quite strange things going on here as well. So perhaps Bilprovningen should have the relationship to their employees instead, and there are a few staff members at the stations instead. And the headquarter thing that was mentioned, all right.
Is it in our school?
Well, I haven't told you what we're trying to model here, so we can keep on adding things here for a few hours if we wanted to. But I think it's quite interesting what you're doing here, actually. You are figuring things out that, okay, hang on, that employee, he shouldn't be, or she shouldn't be part of the station, it should be there at Bilprovningen. Can you see how you sort of interact with your environment here and think? And if I were the designer of this, and you were the customers, we would probably have this conversation. And sometimes you do it this way, standing in front of a whiteboard, and then you give the pen to your customer and ask him or her, could you please draw it for me? I don't get it. And then you have a really, really interesting conversation. So, and I think that's okay. If you have Bilprovningen that you have the employees, aren't they persons in that case? And the relationship is an employee. Well, is that in that case the same table, because that's the customer table? So should that be the customer in that case and not the person? Do you see? So those things usually get out of hands when you don't have the correct context. So you're sort of wobbling around. And then you start to add more entities than you need, and you start to add more attributes than you need, and then you suddenly have a system that is full of redundancy. Good thinking. Questions? Let's see if our remote friends. Yeah, well, that thing here, the question is that if we have a 1 or a 0, I could actually draw that as an arrow instead. And there's actually a symbol for that one as well. I haven't mentioned it for you. It comes later on. So if you feel comfortable with that arrow notation, use it. But me being a UML guy is used to using that condition expression instead. I feel very comfortable with it because I can change it easily to anything I like. But if you like it, do use it. Yeah, so the question is that if you could use any of these two kinds of symbols, that, yep, sure, no problem. One to many, many to one, many to many. And we haven't really talked about it to any extent, but we'll get there in the forthcoming lectures. I'll hopefully I can find another example for you so you can see what happens when you have many to many. You will end up with another kind of problem, especially when you're going to make instances for those tables. Okay, any more questions? Okay, see you tomorrow.